that you touched on briefly, Drew, was public perception and lobbying at the federal level. So I don't know if any of the panelists here from the larger organizations can talk about current lobbying efforts or even PR efforts. I don't know if your organizations, engage public relation firms at a very, working on public relations explicitly with professionals versus just saying, well, what can I do to make sure that the public is seeing what we do in a positive light? And then how much a lobbying effort costs and where, how big would a synthetic biology community have to be before it can draw upon that large resource to fund this type of thing?
That was for me. Yeah, so bio certainly does quite a bit of lobbying. I'm not a registered lobbyist, but there are other, quite a few at bio. And I imagine that the synthetic biology working group that has just formed will be articulating issues that we will be addressing. And I can anticipate a lot of them being in the area of regulation, tax credits, and other bills. And I think right now with the new administration that will be determined in about 3 weeks, we'll have an opportunity with a whole set of faces in both Congress and in the heads of all the different agencies to have some dialogue. And I think that's one of the things I'd like to work on at bio is to start to educate the different agencies as the presidential appointments are made and Congress with what is synthetic biology. So prior to the lobbying efforts as they're developed, more of an educational push of what is synthetic biology, what do we need to do to be responsible, what are the facts. I could envision bringing in our member companies to meet with Congress and have these conversations and try to frame the science in a real positive sense. Does that get to your...
Yep.
And I don't know the exact costs. Trade associations have some reputations.
So, Janet, I just have a question to follow up on that. A lot of the companies you mentioned in your working group are also fuel companies, and I know that Bio has a biofuels sort of lobby group with specific mandates, and there's economic incentives that they have clear sort of economic incentives that they're lobbying on behalf of their organizations for. I mean, what are the things in the synthetic biology working group that would be unique and different than some of those questions and issues that are being tackled, for example, by the biofuels working group?
So we have about a half a dozen working groups in the I&E section, and I'm just going to talk about the industrial and environmental section. And the biofuels working group is a very active working group. And there, as you noted, there are significant overlap in the membership. The synthetic biology working group has a large component of biofuel companies. There's also pharmaceutical representation and fine chemicals on that as well. And so we're going to balance the needs of all these companies specific to the synthetic biology area. So, and the biofuels group will take on more general issues. The RFS has been something that they've looked at, the Farm Bill. They'll look at tax credits. We have a bio-based products working group which will look for tax incentives for using ethanol and other higher alcohols made from biotech routes. So there will be a distinction and division of responsibility, but there certainly is going to be a lot of overlap between the different working groups there. And we work pretty closely. The bio team, the I&E section staff is only 8 people, so we know what other people are working on. There's a communications working group as well. And one of the things they just put out was a 1-pager on what is synthetic biology. But I work closely with the director in communications and looking at that document. So we're working together and then defining which things people are going to take on.
I've actually got a question for Christina in terms of the IBE. It's obviously a relatively small organisation right now, but I can, with the combination of a lot of people from the maths, engineering, physics disciplines finishing undergraduate degrees and jumping into system synthetic biology in the frequency that we're seeing and the uptake through iGEM, and as it spreads exponentially, both iGEM and then graduate degrees and synthetic biology in general, you're getting this rush of members from that respect, and you're also more and more curriculum development going on hand in hand with that across the states and across the world, and we're seeing courses springing up all over the place. So while you're obviously a reasonably small institution number of members right now, I can imagine that the growth could potentially be substantial in the coming years. And I just wondered, is there at present a long-term plan? Is it something like, in terms of the student council, for example, that you could perceive the number of, because there's going to be a large number of students potentially in the next few years, having some kind of distributed and formalised in this? Because what struck me about the student council, which I didn't know about, was how formalised there's an election process, and you have these members, and it's quite a prestigious thing, right? While it's student organised, it's still very formal in that respect in terms of it's prestigious. Is that something that the IBE would consider in terms of, you mentioned you've got 3 regional chapters, expanding globally and looking at formalisation of that?
So we have more than 3 student chapters, but I was just citing that as an example of the 3 student chapters that were participating in organizing the regional meeting. That was sort of the first one that we organized this year. And so the current structure of the IBE, and so the IBE has been growing at a rate of about, I'd say 20% over the past maybe 5 years in membership. It does have the potential to grow much faster with the sort of growth in synthetic biology and other biologically related disciplines, right? In the United States, I think what you see right now is that there's a lot of synthetic biologists, right? If they're introduced to it through iGEM, and they're coming in through basically different disciplines, right? And so depending on the discipline that you come in through, there are different sort of discipline-specific professional societies, right? So I was trained as a chemical engineer. There's an American Institute of Chemical Engineering Professional Society, and there are other ones that are similar for different engineering societies. And what you find is that, at least in the U.S., they tend to be very specifically focused on those disciplines with a subgroup that might be doing biology, right? You see the same thing with other organizations that might be more biomedically focused. And so that was one of my own personal interest in sort of getting involved with the IBE, is because I saw it as an organization that was sort of broadly addressing biological engineering and not necessarily focused on medical applications of biological engineering or even just the applications of biological engineering, but also interested in sort of the foundational aspects of it as well. So within the IBE, to come back to that, I don't know if this addresses the question you were asking. I mean, there are basically, we do have sort of, we have a council, we have an executive council, and there are elections that are held every year, and people run for positions. We also have graduate student representatives and undergraduate student representatives as part of the council, and so graduates and undergraduates will run for those positions, and that gets renewed every 2 years, basically. Depending on, I think, the size of growth of the organization, we may look at sort of adding more positions of graduate students and undergraduates to the council, or sort of shifting the way that the makeup of the council as well. And that will sort of go along, I think, as we see the growth of the organization and also how the percentage of student membership and non-student members basically changes. Does that answer your question?
Yeah. I think the thing that I'm kind of interested in is the sense that we're obviously in a transitional phase right now from the perspective of the entire industry, and we've got startups coming through, but there's obviously going to be this transition gradually where, as the students move through, we're still getting this large number of students coming in, but there's more and more qualified biological engineers or synthetic biologists, if you like, coming through that system, and those are the proportion I would imagine is only going to increase between commercial, industrial, and academic. And I think a lot of the professional thing that strikes me about, certainly from the IET's point of view, is the need for this relationship between professional, commercial, industrial-based trained engineers and academia. And it's something I think that's probably possibly quite new to the I'm again, or maybe I'm being naive, but for the biological sciences or in academia certainly, you wouldn't need an affiliation to an industrially orientated professional body. But now with this juxtaposition of this raise in the number of trained synthetic biologists coming through that are going to take professional roles, is there a need to? Where am I going with this? Is there a need to? I'm stuck now. There seems to be a void at the moment in terms of time. Like, I think I can perceive, like, 5-10 years down the line, there being a large number of professionally trained and with a organisation accrediting trained engineers. How do we get to that point where we have maybe a large organisation that looks at that?
Yeah, so I'm going to kind of move this to a question I had, but I think it might address some of the things you're saying. And if Drew wants to chime in, I think he was also reaching for the mic. I had thought of some comments, not as a bio representative now, but as a member of this community, of what is happening with the development of the professional organizations, which was the title of this session. And I think this discipline is unique because it's not a discipline, and there are many disciplines coming together to make synthetic biology work. And each of the different types of disciplines already have well-established professional societies and norms and expectations. So one of the things I think might be more valuable, rather than developing another professional society, there's a Society of Synthetic Biology per se, is the formation of an umbrella professional society where the members are other professional societies. And the model that I'm familiar with is AIP, the American Institute of Physics. And so if you had a couple dozen other professional societies under another membership society, this could draw from the expertise of these other societies. I think it would couple nicely with efforts and perhaps move forward more quickly. I don't know if that touches on some of the thought you had.
Let me respond by complimenting what Janet just said. I think the history of biotech has relied not only on patents but also on a lot of trade secrets, right? So, for example, if you were listening carefully to the Amyris talk, there is not a description of the strain that was being used for their biodiesel project, and that was a very conscious withholding of information. Now, the reason that's relevant is, for me, if I'm thinking about running a parts fab and I want to make parts that are relevant to people in academia but also in industry, I probably have a situation where those components, their functions are going to be different depending on the culture conditions, the strain, and so on. And so one of the things that's been a little bit missing, I think, from biotechnology in the past has been to take the wisdom and practical experience that accumulates over the years when people try and actually develop projects, and then get that back out into the open, allow that to form some of the content that goes back to the students and others as they're learning to become practitioners, because these are the sorts of details that matter. And so on the one hand, I sort of get what you're saying in terms of a window, and we're looking at professional groups in the future that will be more professional as the communities grow up. But in the meantime, I think there's an additional opportunity, which is to take some of the amazing successful experiences of the biotechnology industry, much of which is bottled up and only reaches back out into academia on an ad hoc basis, depending on personal connections, and try and have that be something that gets strengthened and formalized and shared. And if it's something that has to be coupled via open parts collection or some other things, that'll be interesting to work through. But I take what you're asking about, James, and sort of come back with two different things. In addition to the idea of an umbrella, I think there's an immediate opportunity right now to the English in the professional engineering practices go through, traditionally have gone through a mentorship process, right? And that seems to be missing, I think, from biotechnology.
Yeah, I think I was stumbling earlier, but I think the point I was trying to make was that we do have these already big established organisations that look after a lot of the influx of engineers that and scientists and physicists that we're getting. And so my question is, not question, but we really, I think, need to take this opportunity now as the system moves through and people complete their education and move into professional positions, that rather than letting them drift off to institutions that they find themselves affiliated to by their original degree choice or by their original subject choice, and go into that void, that we use that as an opportunity to drive forward and keep them involved with those organisations and feed that back to the students that we're bringing through. And I think, like, I don't know how you do that in the best possible way. And obviously, these are the efforts that are going on with the IBE and now the IET, which is a kind of top-up approach, really, which is trying to take a very formalised, very well-established, these 40 technical networks that involve 150,000 people around Europe, and how does that fit with the synthetic biology community? And it doesn't necessarily, and that's the discussions that are going on within the IET team and within the exec team that is discussing that. How do you fit that to the current model? But I think I just want to highlight that I think it's a great opportunity that we shouldn't miss, which is as people complete their education and training, that we feed that experience right back down to the students, so that, like, when I'm a student in high school, and I've had this great experience, and I'm being pulled into biotech, the classes that we've talked about this time, or iGEM, there's someone there from an institution that come and say, well, like 4, 5, 10 years ago, I took these classes, and now I'm a practicing professional biological engineer doing that. And that's something that, at the moment, because of the progress the field's made recently and how new it is, how cutting edge it is, isn't necessarily in place.
Yeah. I'd love to see an example, I hope this is responsive, where you have an umbrella organization of, say, professional societies. Let's imagine it's IET and IBE, and over time that would be useful in terms of accreditation of undergraduate degrees, but almost immediately you could imagine, as graduates of iGEM, having an accredited exam of some sort that would be the BioBricks Pro exam or something like that, where the students coming out of iGEM would have an opportunity to demonstrate their prowess with the foundational technical framework of synthetic biology, and then have this be the bridge into some of the professional societies, coordinating all of that with an umbrella organization.
Oh, what's interesting to me, in terms of what you said about mentorship and accreditation, is that a lot of what I was hearing in terms of the benefits you get from a professional engineer's exam, in terms of boosts to your career, is, in my mind, the similar type of benefit you get from having PhD after your name. And the mentorship in, an industrial setting to feed some of that information back in exists in our training, but it exists in the academic setting. So to me, it's more a reflection of the disconnect in how we're being trained as biological engineers, because it's in the academy. In order to get a job in a biotech company and hope to have a career path that is not limited, you need to go do a PhD, but that PhD is in an academic setting that for many, many years could have had an institutional block to looking at non-academic careers in its students. So can we move forward and establish training programs for scientists that are not necessarily as ivory tower based, while still granting degrees that are respected by people who have gone through that ivory tower system?
That gets a little bit to changing the culture of biotech industry, right? Don't you think? Because, as an engineer in another discipline, I was trained as a chemical engineer. I could go out and be hired as a bachelor, with a bachelor degree, and go through this process and get paid a lot of money, and sort of the culture in the industry was such that bachelor's degrees were valued. You can progress up through the ranks, right? You didn't necessarily feel limited. Whereas I think traditionally, my sense is that in the biotech industry, there's a different culture there, right? Probably coming from biology more than an engineering discipline. And so I think that you probably have views on this from your experiences at MIT, starting a biological engineering degree and thinking about this. where the undergraduate biological engineer is going to go, and how do you perhaps try to change the culture within the industry to value a bachelor's degree in biological engineering as an engineering degree as opposed to a biology degree, right? And trying to, so I think it gets more towards that, but do you have anything to add around that, Drew?
I think you pointed out one of the big differences, say, chemical engineering versus biological engineering, in that much of the interest in biological engineering derives historically from science, right? And so this is something that impacts both undergraduate training but also faculty hiring, right? So I think from now having seen one class of undergraduates leave with bachelor's degrees in biological engineering, maybe a third of them go directly into industry, whereas 2/3 go into medicine or graduate study. And a lot of this reflects the interests of a community which is still looking at biology as a science, even within the biological engineering programs. Speaking as a second example of Stanford and the bioengineering department there, which is halfway through staffing up its faculty, I think one of the constructive tensions within that department is the distinction between quantitative biology, taking people who understand engineering and physics and mathematics and wanting to ask and answer questions in biology, versus engineering, people who want to go make stuff, right? And so it's likely to be a case for the foreseeable future that most of the well-resourced bioengineering programs have a tension or a balance or some complementing interests, hopefully, between the science and the engineering. I think in terms of the educational process, there's an opportunity to have internship and training programs. And so MIT, I don't know at the undergraduate level, but at the graduate level, had some opportunities for biotechnology training programs and internships. I had at least one of my students go off and do a 6-month rotation through a company in the middle of his otherwise basic science PhD. So there's a lot of opportunities there, but I think the field is sort of embarrassing in many respects to me for not being more about engineering.
I want to go back, Drew, to your Amherst example. So clearly, I mean, one of your objectives and one of the community's objectives is to sort of get a pre-competitive environment for a number of industrial organizations to develop components or parts that could be used and sort of standardized. I mean, I work for one of the companies that Janet just mentioned, and I'm responsible for budgets associated with funding these organizations, and I haven't heard the value proposition to me. I mean, I'm relatively new to this space, but I have yet to hear a value proposition that says, listen, if our company puts in $50,000 towards a pre-competitive consortium with the objective of developing standard components, this company will get back A, B, and C, and this is the economic return. And that for any sort of industrial organization, this is the language we talk. And I don't know, if this question is more ignorance on my part or if that hasn't been articulated. So I'm curious to get your feedback, Janet's feedback.
The question you're posing is at the heart of the puzzle around how to pay for some of this infrastructure development. And so part of the response to this actually has maybe less to do with professional groups, but very quickly, one of the variables is sort of at what level can an investment be made, and are you resourced to take advantage of the products from that investment, right? So if you're a product catalog business like Emergence, and you're looking, as an example, and you're looking to expand your product catalog, maybe you care less about what you do with the part yourself rather than just increasing the number of things you're selling by a factor of 2 or a factor of 10. I think it's going to be a long time before startup companies who don't have tens of millions of dollars to spend on consortium projects are going to see a lot of direct benefit from this, because we're not yet in a situation where we have battle-tested cellular chassis that are known to work in industrial settings, and you can make a lot of products via biosynthesis, on top of which or within which new components have been made. They're known to work. They're compatible with one another. right? That world just doesn't yet exist in any open sense. And so it's going to take some time for that to come to fruition. Thus, the sorts of returns one would be looking at immediately would be more of the social capital returns that Janet Hope alluded to and so on. And my guess is those aren't going to be sufficiently compelling at the outset on a modest scale, and that it would take organizations of a different scale to be the investors of something like what you're asking about.
Yeah, I think from the other direction, from industry's direction as well, there's always the question, what is pre-competitive versus what is something that the company does that it considers to be its own art. So the choice of a host, I mean, even having not been even at the company for that long, I can tell you people are very religious and they feel very strongly about the innovation that can go towards deciding the kind of host for the particular industrial application. And so I think there's also, in my mind, a lack of consensus on the even the subset of questions that are relevant for some of these industrial players, and I know they're pretty diverse. So maybe there's no real subset of questions at this point, and that I haven't seen that. That's lacking.
Here's a question.
I might just add a real quick follow-up before the next question, too. And I'm just struck here about where the value is going to be with these small companies. And there's a parallel, and I think if you think of the electronics industry, is the value in the parts that are created, or is the value in the assembled product? And I don't think that that's determined yet for this field.
Yeah, I think we have time for one more question.
I think this question relates to, what we've been talking about, but I think just bringing it back to the idea of professional organization. So I'm just curious to know what you think whether you think there are differences or similarities between the kind of fundamental innovation processes across engineering disciplines and in biotech, because it sort of seems that synthetic biology draws on both of those, and that to think about how you might want to structure or work, with students and professional organizations to make sure that whatever support you give feeds into the kind of innovation process that you see happening or that you would like to see happen in synthetic biology. Because it seems to me that there's a bit of a tension there, and possibly differences in the types of innovation structures and pathways that are used between biotech and engineering, but I don't really know enough about it to.
I think there is a tension, and the tension is in part derived from sort of the reality and the promise of the technology, right? Where if I get an email last week from a computer science PhD student who for the first time has seen a video online from Craig Venter, and Craig's converting carbon dioxide to hydrogen gas and, printing genomes from scratch, and that this presumes engineering infrastructure, that all of a sudden some computer science sort of goes, I can make a mapping over to this, and I'll have CAD tools, and maybe I can make a Web 2.0 equivalent for biotech, and an iTunes store comes into being for BioBrick parts, and I can take a lot of the lessons I'm familiar with in quickly developing innovative products or services and capitalize on those. Contrast that with the stories of Amyris, the stories of commercializing many of the other immediate technologies presented here at this meeting, and that's a much more traditional. So your question's a real good one, and I think it should give us pause in thinking about how to mentor students and how to train them, where we give them access to the realities of practice today without constraining them and thereby, imprisoning them in this future, which is the past, right? And so it's a little, I don't know the best way to do that. I'll just sort of celebrate the challenge of your question.
Just a slightly related question, or maybe a feedback from local students here. I was talking to a couple of students who attended many sessions in this conference, and they were telling that it would be nice to have some kind of a tutorial-based session also on the sidelines of this conference, so that, because not all of them are aware of what exactly SB is, the synthetic biology that we're talking about here is, and some come from the computational background and they might be interested to pursue this as a graduate course, and that would be kind of nice.
I was struck by the fact that there are a lot of new people here, and we're not doing a good job necessarily of making entry easy. And some people would say there's a strength to that approach, but maybe not.
All right, so I think we should end the session and adjourn for lunch. Thanks everybody for participating.